Have you ever wondered how a computer works? These technological marvels have woven themselves into the fabric of our lives, serving a multitude of roles from workstations to entertainment centers. Yet, despite their ubiquity, the intricate mechanics behind their operation remain a mystery to many. What makes these machines tick? What are the key components that enable them to carry out the tasks we set for them, from the simple to the complex? At the heart of every computer lie several key components, each playing a vital role in the overall function of the system. From the motherboard, the nerve center of the computer, to the CPU, the system's brain, each component contributes to the remarkable capabilities of these devices. But how do they actually function? Let's dive in. At its core, a computer is a complex machine made up of several key components. One of these fundamental parts is the motherboard. Imagine the motherboard as the heart of a city, with roads leading to various buildings. These buildings represent the different components of a computer. Just as roads connect buildings for smooth transportation, the motherboard connects all the computer components for seamless communication. Now, these roads on the motherboard aren't made of asphalt. They're thin metallic pathways called traces. These traces guide the data to their destinations, ensuring that the CPU, RAM, and other components can chat with each other efficiently. The motherboard also houses various sockets and slots. These are like parking spaces for the components, each designed to hold a specific part, whether it be the CPU, RAM, or expansion cards. It's like the central hub where data travels between different parts of the system, so the motherboard essentially orchestrates the symphony that is your computer's operation. One of the most important components is the CPU, or Central Processing Unit. It's essentially the brain of the computer, controlling all the operations that take place within the system. The CPU interprets and carries out instructions from the computer's memory, coordinating the activities of all the hardware devices in the system. CPUs are comprised of several cores, each capable of executing instructions independently of the others. This allows for multitasking, or running multiple processes at once. The faster the CPU, the more calculations it can handle, leading to a smoother, more efficient computer experience. But it's not just about speed. The CPU also needs to be efficient. It has to manage heat, power consumption, and data flow effectively to avoid bottlenecks and keep the system running smoothly. So the next time you're streaming a movie or playing a game, remember, it's the CPU that's making it all possible. Think of it as the powerhouse of your computer. Next we have RAM, or random access memory. Picture this. You're baking a cake and you've got all your ingredients on the counter. Those ingredients are like the data in your computer. Now, where do you put the ones you're using right now? You can't keep going back to the pantry for every single item. That's where RAM comes in. It's like your kitchen counter, holding all the data and instructions that your computer, or in this case the baker, which is the CPU, needs to access quickly. RAM works closely with the CPU, providing it with the necessary data to execute functions efficiently. When you load a program or file, the CPU places the data it needs to process in the RAM. This allows the CPU to access and process the data at lightning speed. So in essence, RAM is essentially the computer's short-term memory, holding on to data for immediate use, much like our baker's countertop. Then, there's the storage drive. Let's imagine it as a vast library filled with books of all kinds. These books represent the data stored in the computer, including the operating system, applications, and personal files. It's the place where everything your computer needs to function and remember is kept. Now, there are two main types of storage drives: hard disk drives, or HDDs, and solid-state drives, or SSDs. HDDs are like traditional libraries, with books neatly arranged on shelves. They store data on magnetic rotating disks. Although they have a larger capacity and are more affordable, they are slower and more susceptible to physical damage. On the other hand, SSDs are like modern digital libraries. They store data on interconnected flash memory chips, providing faster access to your files. While they may be more expensive, they offer speed, durability, and energy efficiency. In essence, a storage drive acts as the long-term memory of your computer. This is where your computer keeps everything it needs to function and remember. In addition to these internal components, computers also have input and output devices. Now, what could these be? Well, they're the tools that allow us to communicate with our computers and vice versa. Let's start with input devices. These are the peripherals that let us send information to the computer. Keyboards, mice, touchscreens, microphones, webcams, all of these fall into this category. They allow us to provide instructions to our computer, whether that be typing a document, clicking on a link, or even commanding Siri to set a reminder. Then we have the output devices. These are the peripherals that allow the computer to send information back to us. Monitors, printers, speakers, these are all examples of output devices. They display the results of our commands, whether that's showing us a video, printing out a report, or playing our favorite song. These are your computer's ways of communicating with the outside world. So, how does it all work together? Well, think of it like a busy city with roads connecting different areas. The motherboard is the city layout, the roads are the data paths, and the components are the buildings. When you power up your computer, it's like the city coming alive with data zipping down the roads going to and from different buildings. The journey begins with the CPU, our city's brain, which retrieves instructions from the storage drive, our city's library, and loads them into RAM, our city's workbench. Imagine the instructions as a recipe for a meal. The CPU is the chef who reads the recipe from the cookbook stored in the library, then gathers all the necessary ingredients and tools on the workbench to get cooking. Once the instructions are loaded into RAM, the CPU gets to work. It processes these instructions, performing tasks like chopping vegetables or stirring the pot, which are akin to running programs or displaying graphics on your screen. And it does it all at lightning speed, faster than the best chef in the world. But it's not just a one-way street. As you interact with your computer, the input devices, such as your keyboard and mouse, send signals to the CPU, like customers placing orders at a restaurant. The CPU processes these orders, cooks up the dishes, and sends them out to be served, which is the output displayed on your screen or sent to other devices. And just like that, your computer is humming along, processing data, running programs, and responding to your inputs. Every component, from the CPU to the RAM, is working in harmony, making this intricate dance of data flow possible. And voila, your computer is alive and kicking. It's a marvel of modern technology, a symphony of data flow, playing out every time you use your computer. So next time you boot up your device, spare a thought for the amazing process happening inside. It's more than just a machine, it's a bustling city alive with data. As you interact with the computer, input devices send signals to the CPU. This interaction, as simple as it seems, sets off a symphony of activity within the machine. The keystrokes, mouse clicks, and voice commands are all translated into binary language, a series of ones and zeros. This binary data is the universal language of computers, easily understood by the CPU. Once the CPU receives these signals, it springs into action. It fetches, decodes, executes, and then stores. This cycle, known as the instruction cycle, happens at lightning speed, faster than the blink of an eye. It's this speed that allows us to experience computers as responsive and intuitive devices. Remember the RAM? It's standing by, ready to offer up any data the CPU might need. It's like the ultimate assistant, always prepared, always efficient. Once the CPU has done its job, it's time for the output devices to take the stage. The results of all this processing are sent to your screen, speakers, or perhaps even a printer. But let's not forget about the storage drive. It's there, quietly holding on to the operating system, your apps, your files, and all the other data your computer needs. It's the long-term memory of the computer, ensuring nothing is lost even when the power is turned off. And there you have it. The symphony concludes, the conductor lays down the baton, and the result of this intricate dance is the output you see on your screen or hear through your speakers. It's a complex process, but one that's beautifully orchestrated within the confines of your computer. And that's how a computer works. Each component plays a crucial role, from the motherboard acting as the grand stage, the CPU as the conductor, RAM as the dutiful assistant, to the storage drive as the faithful librarian. This amazing interplay of hardware and software, of input and output, makes computers one of the most remarkable inventions of the modern age.